Alright everyone, and welcome back to another tutorial on our RTS series, and today we're going to be building a quick new feature of being able to right click under some trees here. And this will be part of our RTS on building the units to gather resources. That will be our next milestone to achieve. Now, of course, this at the moment is they just moved to their location, and they also avoid the trees because they are part of the navigation baking. But overall, this will set us with some basic ideas for us to implement AI for units on future parts, and it also will allow me to showcase you some issues we are going to be facing. I'm going to address also a lot of bugs in this part from the previous part, but overall this will set us into a nice foothold so we can continue building the RTS. And once we do the AI for the units, you're going to see that we're going to be delving deeper into RTS mechanics and systems. While it might seem simple to just make a unit gather resources from this area, this is going to be turn out to be quite a complex task for us to achieve due to a lot of issues we have with the RTS genre. But I'm going to of course show you everything and with step by step with each part. So let's go ahead and let's go now back to our project where we last left off. And I think I'm going to leave the reference project over it so it will be easier for me to switch. So the last one was the RTS part 3, and I'm keeping track of the changes and also doing backup versions so I don't lose any progress. And this was our last part where we made, I believe it was the navigation for the units themselves. Alright, so let's go towards some of the steps we're going to do. So let me first add the 3 objects for our RTS here before we do anything else, because it's cool to add new stuff to our project. So let's go towards RTS objects and let's build a new folder for our resource units. And here we'll be placing our tree. So let's go ahead and add a CSG mesh, and of course we're going to use these. So let me first add one to be the pivot point for our tree, then let's add this CSG, not CGS, and let's add a cylinder to be our trunk for the tree. I'm going to grab here the top part, hold Control, make like something like this, and I think it's a little too big, so 0.3 there. And of course, to prioritize performance, let's reduce the amount of polygons. And now let's build the tree part, the leaves. So let's add a sphere, put on top of the tree, increase the size until I think it's appropriate. I think 1.5. It's going to be a little bigger than the reference project, but I think that's all right. Let's decrease the amount of polygons to 6, and here I can also reduce the amount to something like, yeah, let's leave it something like this. Now we have our basic shape. Let's save this as part of a scene. So let's save this CSG branch as a scene, and let's go under RTS objects, resource, and I'm actually going to add a new folder here. And let's call this one wood. So this will be wood resource, and we can also later remanage these as we see fit. For now, this will do it. So now we have a separate resource for our wood, which is going to be our tree. So I think now we should be able to delete the scene because we're going to have access to the save scene. Next, we want to bake this, but it's only going to allow us to bake if we have another node as a root. So let's add a new node and let's make this as the scene root. So now we can actually go to our CSG and bake the mesh instance. So we can now save the baked mesh for use later. So let's save this as RTS objects resource wood, and let's call this one mesh source, just like our unit. So we have access to the mesh itself and the source. And let's open here our unit and see, and it's actually only called mesh. So let's rename this to fit our style, and this one should be called mesh source. So we are following the same structure from the unit, which also has a mesh source using CSG shapes. Now let's save this scene. Let's go back to our main scene. Now we're going to need to build the Rts Object, the tree itself. Let's add here another node to store our resource for the wood. And for now, let's call this as resources. And this is just a simple group system we are doing. Later, we'll probably use some kind of filtering to gather all the objects inside a big list, and we let the RTS world handle it. So this will be our tree. So let's grab the resource back here. And this is the unit. It's actually the tree we want. And this will be our tree object. So let's right click and save this branch as an RTS source wood. And let's call this as main. And we can also call this as tree. And I think I'm going to call this as free01 actually. So we're going to be name this as a tree object and not main, because main doesn't make any sense in this instance because we only need a basic tree. But I guess because this is, yeah, you know what? Let's call this main. And the wood, we're going to actually, yeah, let's leave it this. I will be calling it tree later. So this will be the wood reference object. Yeah, that works. So now we should also, I don't think we need scripts for this for now. So now let's go ahead and now to have our tree object, I am going to split them. I'm going to make some copies, but before we start making copies and stuff, let's add them to the RTS map so we can do the baking for the navigation. So whenever we do bake, it's going to create holes where the tree are so our units can avoid it. Now it's just a matter of duplicating it until we have made some structure for a forest kind of thing. And you don't need to be precise about this. It's actually better if you don't, to keep it this organic. And I'm going to also show you later that we're going to have a big issue with iteration for the trees and also with the collision stuff. But I'll show that stuff later. So yeah, let me just grab some here. So just to make this a little more organic. Yeah, that should do it. So now we have a bunch of trees. We can now grab our navigation region and call in for a bake. And as you can see, we have now some movable paths for our units. Now if we run our project, we should be able to move our units and they should not collide against the trees, but rather avoid it. So there we go. And you can see the path information populates the scene and we can move amongst our tree objects. Okay. Next thing, let's go back to our units now, and I'm going to be hiding the debug information for our path, and we'll start fixing up stuff here and some changes that I have done for the project. So let's now quickly document these debug functions. So this debugs the unit's target position, and this one debugs the points in the path. And I'm going to do this so later on the project if I forget how these are being used. This is just for us to remember what they're being used for. So we also have a new one here, and this one debugs the current unit's position on path. This one is the debugs the path change. Okay, now our units should be able to move without any sort of debug information visible to us, which is something that is desired. So the next thing I'm going to also be building, because it's a feature and features are cool, let me hide this, is if I switch over my reference project, which I believe is this one, and run the scene, you're going to see that I made, and this is not the reference project. Yeah, it's this one. You're going to see that I made a simple context world here. Whenever I right click, it's going to point towards that. And this will be useful for you to know also some of the bugs that are happening behind the scenes. So we're going to be building this. And this animation we are going to be doing with code because it's faster and modular and allow us to reuse that later. So I'm going to zoom out to know this is the reference project because the trees are different from our working project, so I'll be able to remember that. So we're going to be building that. So another thing I'm going to do is to rename the components. So I thought about a better name to be node components, so it states more clear what it does, because Rts Objects is going to have a lot of different things belonging to the Rts genre as objects. So I think this rename here is worth it. And let's see if any of the code breaks with this change. And I don't think it does, so no references are being broken. So let's add now a new folder to our Rts object, which is going to be that 3D UI thing we're going to make. So let's call this 3D UI. And we're going to be building here the one we just saw. So I'm going to be actually doing it through scripts instead. So let's build here a new script. And we're going to place it inside of our Rts objects 3D UI. And this is going to be called main. So I'm going to simply, no, it's not letting me. Oh, here it is. So I was editing the inherits. No, is actually the path where we're going to store the script. And let's just call this main. So we're going to have functions that are going to build that thing for us. So let me just save that. So let me just paste here the code that I did for the reference project. And all this does is just create a couple of things, and I think you can actually get rid of those override methods. So we have here some issues with this. Let me see what that is. It's because I have switched the name to be node share components. Yeah, sure, why not? Instead of node components, let's rename it to node shared components. Now it's even a little more different. And because Godot does not have updates yet, it doesn't know that the path has changed, which is an issue. So let's reload the project so it updates and removes that error very quickly. So let it reload the project. Now the error is gone. So let me see here. We have added a sprite circle. And yeah, so this code that I have done for the 3D UI thing is actually very simple. We have a function that is going to be the animation function, and we have a function that's going to create that circle object. We're going to be reusing the sprite 3D circle selection thing, which is just a single sprite we used for the unit selection. We can use that to create that 3D UI thing. So the scale to expand fade out, this method here is a static method that uses an object to expand a expand vector tree size and a duration. So it's simply going to access the tree for the objects that is being expanded is going to create a tween. So a tween is something we use to create these types of animation, and it's going to, once it finish the animation, it's going to get rid of it. So we're going to tween this is the order of execution. So you grab the tree, you create the tween, then you're going to use it to tween some properties. So this is just doing a lot of things. Just by using the dot, we are actually doing different things here. So up to this point, you create the tween, and then you're accessing the tween again and asking for to use it to build an animation. So we're going to pass the first argument to be the object we're going to expand. We're going to change its property scale. We're going to expand to the given argument for the function and by a given duration. We also now are going to be changing the animation. So whenever you do set trends, it's going to change the transition type for this tween property animation based on the duration and the values you passed here. So the tween animation we want to use is sign, and we also want to set its ease, which is basically the order of animation of the sign. So you can make it fade in or fade out. There's a couple of options, and we're going to use ease out. And finally, we're going to now grab the object we want to expand to grab its tree, and we're going to create a timer. By the given duration we pass here as arguments, we want, whenever it's timeout, we want to connect a new function that is going to basically delete this object. So this is a readable object, a deletable object that is going to automatically delete itself after it has been born. So this is just that 3D UI thing. Now this function here is going to be used to reuse this function, because this function just handles the animation thing, but now it's going to use it on a circle object. So that is why you need the sprite circle reference here to preload the 3D sprite selection from the units, so we can store here as a packet scene. So this function needs a color for whoever calls it and a position to basically place this object. So we're going to instantiate, and whenever you do instantiate, this is almost like doing a .new whenever you add variables and stuff. It's a little bit different, but it works almost as that. So whenever you instantiate, it actually creates a copy behind the scenes inside of Godot, but it does not add to the tree yet. So it does not belong to your 3D scene here. It's not being added as a node or whatever, but it exists on memory as a separate object. So it's quite important to do the instantiate process. Next, we want to set its position back to wherever we set it as an argument. And because this sprite is centered, we want to lift it above the ground so it doesn't have the Z fighting with units against the floor. As you see here with the unit, it's floating above the pivot point. Otherwise, you have issues with Z fighting, as I have shown on the previous tutorial. So that is why this magic number exists here, which is just to lift the sprite above the ground. Next, we're going to call the object caller. So whoever called this function is going to need to pass it as an argument. We're going to access its tree, its root node. So we're going to grab basically the root of the actual scene that the object that has called this function is going to use. And we're going to finally add that circle object. Then next, we're going to assign the new function to animate that object. And we're going to pass here as arguments the object itself. Next, the vector we want to expand, so we're increasing its size to basically the scale of this object to basically 2, and we're going to pass the duration of 0.2 seconds. So this allows us to call this function from other objects, so we can create that order thing for our RTS. So now the last thing remaining is to access the RTS player and add the code here back to it. So we can do this. So I'm going to duplicate the script reference. I'm going to access my 3D UI thing. I'm going to pass here, and I'm going to simply place under here. And now this one is called the 3D UI. And now we can access these to create a function that's going to actually do that. So now whenever we move the units, like let's see here, for instance, this function here, which is hiding stuff, we can say that whenever the selection is higher and we move units, and let's actually enter the code for this. We can do it right here, because this is moving units to somewhere in the map. We can actually call that. So and actually going to show you a change you're going to do for the entire project as well. So let's call the script 3D UI, so we can actually place that order. And here it actually showed. And let's just, so who is calling this function? It's ourselves, and we want to place that circle on the mouse collision on map. And now this script is going to be accessible, it's going to create that expanding circle, and it's going to show up. So one of the things I want to show you is that the autocompletion doesn't work if this was not a static method, because we have passed the type here as a script. So let me show you what happens if I go to my 3D UI thing and remove this static function from both of these declarations, so it works. And I go back to my RTS player. If I go here where I called that script, so I believe it was from the move units to mouse. If I go here and specify another method, one that doesn't exist, like create gold, you're going to see that Godot is not going to throw an error. And this, from my point of view, is a big mistake, because we don't have this function whatsoever inside this object. This ref counted script doesn't have a create gold, so in my opinion this should throw an error for you. The way you can fix this is by going here and omitting the type. So I have researched a bit, and this seems to be a decision by the engine itself to allow you to, if you specify a type, it's not going to autocomplete the methods from the preload, but if you omit the type, because it doesn't know the type, it's going to forcefully autocomplete from the preload. So it's going to try to fetch a type for this constant from the preload function. And because it does this by reading the preload, it's going to actually detect on the script that this function does not exist in this script. So this is very powerful. And in my mind, just by having the script defined here, this should not hide this create gold function here. So if I undo on the script thing, it's going to see that the error is gone. It should still show up, but if this is a decision by the engine, you can just omit the type, so have this autocompletion auto-detects whenever we have a function that does not belong on that script. So now let's just undo that so I can have this function back again. And let's actually remove the script declaration. So whenever on your project you have the script declarations, then you can see that even here something is wrong. So this is because it's saying that it's non-static function, and these functions were static before. So let's just assign them back. So whenever the code you have defined as the type of our script, we're going to basically be removing that. So I don't remember anywhere else. I think we don't have these declarations. Only the RTS player seems to have these preload scripts, so we should be fine to go. So now that we have done this, whenever we move the units to the mouse using this method, is going to generate also a expanding circle based on our script, which is this one, and is going to run these functions. So whenever we run our project, so when we right click, nothing happens, but if we have a selection and we right click, boom, we now have a circle feedback for us to know that we move our units. And you're going to see something quite interesting. We are right clicking here, and the coordinates for the position it's here. So this was something I wanted to do, and it is also showing another bug I have not found on the other version. And I'm actually getting a couple of errors here, let me see, and it's because of this as well. So let's fix this first. So this bug is very verbose because every unit is spamming it. Basically it means if the origin and the target are in the same position, this function will fail because it doesn't know the vector up that is this function uses, so it fails and it prints that debug function. And of course I have told on the previous part that we're going to do another code for this, so the units will look towards the path position using another algorithm code for the math. But for now, let's just fix this simple issue here with this command here. And basically all this is saying is that if the global position is different than the next path point, then this means that they are not the same position. We are allowed to rotate towards the next pathing point. And this will change because we're going to work with targets and not only paths. So units will target 3 units, but it should fix all of these errors here as well. So that's one less error to deal with. Now we just have to take care of this offset thing, because I'm right clicking here and you're going to see that the coordinates, it's something wrong. You're going to see that as far as you get, they are being collided on the wrong position. So this was a mistake by my part on the math here whenever we do the calculations from the camera. So let me see where I did that. I believe it's from the RTS player. Whenever we generate those Raycasts, I passed normals, but I did not pass the camera global position towards it. So let me fix first the get mouse position collision on points on map. So this was used to collide against the terrain to remove units. What we need to do here is simply to fix this by adding the camera global position to also be used as a starting formula for an array. So the idea here is to generate an array from the camera towards the mouse position to collide against the terrain. If I don't pass here the targets without the camera position, what's going to happen is the array is going to start for the camera global position and is going to be projected towards the array normal multiplied by this. What that means is that the ray normal is a very small ray, so it's going to be almost like here, very close to the floor, and it's going to use the camera global position as a starting point and it's going to project towards that. So this offset is because of the wrong calculations. Instead, what we want is for the target to be the global position of the camera plus the ray norm of the camera and multiply by the camera ray of view, so we can have the ray reach somewhere place, because the ray normal is just the direction the camera is pointing towards. And I also found a way to delete this magic number here by doing camera.far, and we can actually isolate this under a parentheses here. So far represents the distance for the far killing for the camera. So this is basically a property that every camera has that basically allows you to set how far the camera should be able to see. If I do here editable children on the camera, just so I can enter it as a preview, and I believe on the inspector I can change this because I'm using editable children. I'm going to see far. This is the property we are using to multiply the ray. If I reduce this, it's going to see that's going to call every other object. So this actually solves both of the issues we have. We disable the magic number and we use actually a property of the camera to multiply the ray normal. So this will always work and you don't have to deal with any magic number. So this is a big win for us. So this should fix that issue, and if I run the project from this change, you're going to see now that the target position is going to be accurate and the circle is almost on top of the mouse position, which is exactly what we want. And there's also a issue with this because the AABB code we used also used a Raycast projection method. So if we go here towards where we store the AABB calculation, which I believe is under selection manager, and we have a function called select by AABB, and guess what? It also uses the camera ray projection, so we also need to pass here the camera global position. So instead of this, the code is going to change, and the changes are going to be that we're going to project the ray first by the global position of the camera. Next, we're going to use the global position plus the camera normal, and we're going to multiply by the camera far. So this is also going to improve the accuracy of our AABB selection methods to select units. I don't think I have detected that because the AABB code is quite a little bit finicky, but now it should be a little more precise as well. So if I go here back to the RTS unit, we can also debug that later. So this is also should be able to fix this issue with wrong calculations using the camera normal ray. The next one I want to show you is a change for the entire project as well regarding the script names for file paths. So what I realized is that if you have this type of path, it's easier to refactor than having these types, because this type of path is actually simple and faster to code, but it's very hard for you to find it later, because this is an actual 100% path that represents where the script is placed. It's actually under our resource files for the entire project, which is this folder. Then it's going to access the RTS objects, the 3D UI, and the main script. So let's say you rename this folder to be 2D UI, and now you need to rename every single script in every single object. As I've showed you, there is a function for this for Godot, which is find and replacing files. And we can simply pass the entire path here and replace for the other path we want. If we did with relative path, it's going to be a pain in the ass for you to find in every single script which times you used one specified path or maybe two, depending on where the object is. The point of this is that by having a unique prefix name, it works like an easy way for us to replace it later if you want to reformat due to a file change. So actually, if you do the full path for the resource, is going to be better than just having it as short as I showed you. This is a way you can do it, but I think that using the full path is going to bring us a little bit better management on the end of the road. So whenever you have a preloaded script, just use the full path, and if you later decide to change or anything, it's going to be easier for you to change the entire thing for the project, because you can simply do select the full path and go towards a replacing files. Find this and let's say replace this with, let's say you wanted boogie and stuff. It's going to replace for every single file, and it even works on shaders and stuff. So I think this is better and a robust method of keeping scripts. So I believe this is another change you should apply for your project. So now the next thing we're going to be doing is going towards my reference project, and we're going to be doing this target thing on the tree itself. And as you can see here, it shows the bug, but I'm not going to spoil it. I'm going to show you it in action. So let's go ahead and code this. So how can you target units by the AABB? And we're going to use their coordinates to move units towards them. So we're back here in the code, and let's go towards our RTS player and build a function that's going to get based on the AABB to grab from the tree objects. So we're going to have a function that calls for it's going to return a dictionary collision data information based on the resource objects we're going to use that is going to intersect with the mouse by the AABB. So that is what we're going to be doing, and it's going to give here an error that we do not have the object resource node tree. So let's do that here. Let's copy this one and let's change the code, and I believe this is the path we want to use, and now it should be good to go. So all this code does, the return resource, it needs the mouse position, it needs the camera, and it's going to check for every resource object which is expected to be inside the resource node tree. So we're going to check for every single of its children for the resource. We're going to check if our selection manager can select them by the AABB using the resource as node 3D and the mouse position and the camera. And if that's the case, we're going to return a dictionary with some information, because this is the dictionary information. Now, this is super dirty. I don't like to use strings for things like this, but for this simple tutorial part, this will be enough. Just to showcase you the complexity of the RTS, we're going to simply want to target a simple tree, and we need a couple of things here. So if we can select them by the AABB, we're going to return the collider as a resource for the interaction, and if we also found it, we're going to return its global position as well. If we do not found any resource to be selectable by the AABB, this is not going to run, and we're going to return an empty dictionary, almost like the Raycast function works from this one here. So this is basically just like that. So now we can use this function inside of our RTS player whenever we right click under something. So here we're going to change a couple of things. So whenever you right click, we currently are moving the units if our selection is higher than 0. Now we're going to change to a couple of things. So this is the change. So we are still keeping the function as it was. So if we found the selection and we do not have any resource, we're simply going to move the units. That has not changed. But now we are saying if we have a selection size, we're going to now return a dictionary using that function we just built. And if we have valid resources that is going to be selectable, we are going to now grab that resource. So we're going to grab its position, and we're going to check for every single unit in our selection to move towards that resource position. And we're also going to generate a new expanding circle for that, because currently the expanding circle is just being called for the move to units to mouse function. So that is all the code to do this, and I'm going to show you the first issue we're going to have. So in order to represent this issue, I'm going to need to go towards my resource, and I'm going to grab the first tree on the list. I'm going to put up close here, and let me see where that lands. So it's this one, and I'm going to grab the last one on the list and going to put behind it, and I'm going to display to you the bug. So the one towards the 10th is the last one. Yeah, that should work. And we also can rebake. So we have accurate collision information here, and that should work. So what's going to happen is the collision code works, and we can actually toggle between both and move our units towards them. So this is already working. The issue belongs when we have them overpost like this. You're going to see that for now it works. The first tree here is the one closest to the camera, and whenever we right click, it grabs the first one. If I rotate now towards the back of this tree and I select it, look what happens. The tree on the top here is being selected, and the first one is this one. So this is the one that should be selected. So if I right click just by the corner here of the AABB of this tree, you're going to see that it works. But if I hover over this one has a higher priority. And why this is working like this? This is even worse with more objects. So if I put them overlapping like this, the ABBs are going to be overlapped, and one of them is going to be prioritized, which is this one. So if I rotate backwards and I right click, that one is still being prioritized, where this one should be the first one. And why that is the case, you're going to see that I almost cannot even click on the middle one, just the top and the bottom one. So the order here is messed up, and that is because of the iteration order. Because guess what? The code here that is going to check for the resource objects, if they intersect with the mouse, is checking for every resource under our resource node getChildren. And the order of this code, if it finds an object to be selectable, is going to skip the function entirely. So it's going to iterate through the first object in the list, then go all the way to the last one. So always the first object is going to have a higher priority. That is why the first tree is always being selected, even if the second one, which is the last one of the list, is on the front of the camera. Whenever you click here, it's going to iterate through the node tree and is going to find that the first one already collides. So this is the draw box and the mouse already collides with that one, so the function is going to skip, where we should be able to check for every object until it hits the end of the list and grab the closest one towards the camera. So this should be the one selected, not that one. So that is one of the issues you're going to have with RTS, that it's a bit unexpected, but the order of this list matters. So the way that we can fix this inside of the code is now to have to account for the distance of the object towards the camera. So you're going to see that in order for us to implement this inside of this function is going to grow to be actually almost double the size. So just for us to filter out every other object based on the distance towards the camera, this is the amount of code we put into it. So I am starting running into this issue of the tutorials have an increased complexity. So because of the RTS genre and these types of issues, I think the tutorials are going to get a little bit more complex as we are going to move towards doing the AI and doing the RTS word processing thing. So hopefully you were able to follow along this part, but from here on out I can't promise I will keep this thing simple. There's no way to simplify this. You have to filter every single object to grab the nearest one towards the camera. The way we can simplify this is using physics collisions, but this does not apply to RTS, so you have to do it this way. So let's see what changed here inside of the code. We have the addition of potential targets, which is a temporary var for this function. So it creates an array of nodes 3D. So for the first for loop here is going to check for every single node, and if they are selectable by the AABB, we're going to add them to this list of array. So these are potential targets. So whenever you right click someplace else on the tree here, is going to see which ones have the bounding box be targetable by the mouse, and is going to add them inside of this array tree. Next, we're going to see if these potential targets are going to be the nearest closest to the camera. So if we have potential targets as well, so if we do not find anyone to be selected by the AABB, this function is going to skip, and it's going to skip all the way to the return of the empty array, of the empty dictionary. So that is what it's going to do. But if we have potential targets, now we need to filter them out based on distance. So we're going to need the closest resource we have at the moment, which should be the first object, because it's the first one we have one. Then we're going to iterate again for every single one. For every single one inside of the potential targets, we're going to grab the distance they have at the moment. So this is the current distance we have towards the object. So the closest resource, global position, distance squared to the camera, global position, is the closest one we have towards the camera. If while we are iterating through this, we're going to check if the one we are doing right now, if it's global position distance squared to the camera, so basically if its distance to the camera is smaller than the closest one, because if we find that this object in this list how it's closer to the camera, this is going to replace our closest resource. And we're going to keep running this loop to find the closest one. So it's going to iterate through all of the nodes that have been selected by the AABB, and one by one it's going to see which one is the closest one. It's going to assign that back to the function here as this variable here. And whenever we finish running this for loop, it's going to return the closest resource as a collider and its global position under the position. So whenever we call this function here again, and we use the return elements from its dictionary like its global position, now it's going to grab the closest one. So this function also now filters them out based on distance. So all of that code just to fix that issue. So now if you run this thing and you select some units here and we right click on the tree, the closest tree towards the camera, which is this one, should now be targeted. And if we switch the order of the three nodes here is still the same, but here it should now prioritize the first one closest to the camera, which is the bottom one. And you're going to see that that works perfectly as it should. So all of that code just to filter which object is closest towards the camera. And the code now should also work with everything else. And if you switch the order, it should now always grab the first one closest to the camera. So there we go. Now we should be able to target these node trees. So all of this just to fix this smaller feature here. So hopefully you like this video and stick them out, because the next parts are going to be pretty important, and we're going to be keeping building our RTS jar. So we're going to make units having a AI finite state machine to collect wood from the trees and stuff. So hopefully you like this video, and I'll see you on the next one. So thank you guys for watching.